Okay, thank you. Hi everyone. So last time we spent the whole hour to solve the end of chapter 3 problems. And today we are going to continue on solving the end of chapter problems. And probably next time we're going to move on to the next chapter, chapter 4. Okay? Okay, so the first problem for today is problem 3-31. So $1,000 is borrowed for 1 year at an interest rate of 1% per month. If the same sum of money could be borrowed for the same period at an interest rate of 12% per year, how much could be saved in interest charges? So we are solving problem number 3-31. So for an interest rate of 1% per month, okay, let me write down. For the interest rate of 1% per month, so n equals 12 months. Okay, that's we are going to use. Because there are 12 months in a year, we are going to use n equals 12. And using the formula, f would be 1,000 times 1 plus 10%, 1%, so 0.01 to the power 12, right? So what is this value? So this is the same as 1,000 F given P 1% over 12 years. So the compound amount factor for 1% is provided in page number 598. So F given P at 12 years, so the factor value would be 1.127. 1.127, 1,000 times. So this is going to be $1,127. Okay? And for an interest rate of 12% per year, for the interest rate of 12% per year, we are going to use n equals 1 year, right? So using the same formula, F equals 1,000 times 1 plus 0.12 to the power 1 this time. And another expression is 1,000 times F given P 12% over 1 period, 1 year. What is this value? 12%. So 12% is provided in page number 614, f given p for 1 year would be 1.12. So this vector value is 1.12 times 1,000. So how much is that? $1,120. Okay? So you need to compare these two values, $1,127 and $1,120. So how much savings in the interest? It's going to be just $7 difference, right? So the savings in interest would be $7. Okay? So this is the problem number 3-31. Now, next problem is 3-33. So the local bank offers to pay 5% interest on savings deposits. In a nearby town, the bank pays 1.25% per 3-month period, that is quarterly. And a man who has $3,000 to put in a savings account wonders whether the higher interest paid in the nearby town justifies driving there to make the deposit. Assuming he will leave all money in the account for 2 years, then how much additional interest would he obtain from the out-of-time bank over the local bank? So this is the problem number 3-33. So here, let's first work on the local bank. Okay. So for the local bank, we want to know the future sum of F given $3,000 is the present sum, right? So F given P, and the local bank offers 5% interest, right? Over 2 years, right? So N gonna be 2. Or if you want, you can use this another expression of this formula, which is 3,000 times 1 plus 0.05 to the power 2, right? And let's get this table value. The compound amount factor at 2% is given in page number 602. And the value is 1.040. 1.04. So 3,000 times. How much is that? $3,012. Okay. Oh, I'm sorry. I was looking at different value. I'm sorry. The compound amount factor, and we are looking for the 5% interest rate, and the compound amount factor at 5% is provided in page number 608. And the value is 1.102. So 1.102. So the answer would be $3,306, right? Sorry to make you confused. Okay, now the next case for the out-of-town bank. They are providing 1.25%, right, per 3 months period. So we are going to use I equals 1.25%. Then what about the number of period, n, in this case? It's not going to be 2, right? Then what number we need to use? It's going to be 8. Why is that? Because there are 8 quarters in 2 years, right? There are 8 quarters in 2 years. That's why we are going to use n equals 8, okay, for the out-of-town bank case. So using the same formula, F equals 3,000 times F given P, and 1.25% over a period, okay? So 1.25%. So if you look at the page number 599, it provides the compound amount factor for 1.25%, right? And you are looking for the period 8, so it's going to be 1.104. It's going to be 1.104, 3,000 times. So how much is that? $3,312. Okay? Slightly different. So this bank provides additional interest of $6. Is that correct? So I recommend him to go to the out-of-town bank. Okay? So the additional, sorry, let me down here. So additional interest amount would be $6. Okay? Okay, then next, let's solve problem number 3-37. Is that 3-33 we just solved? Okay, so let's solve problem 3-37. A sum of money, Q, will be received 6 years from now. At 5% interest rate, the present worth of Q is $60. At the same interest rate, what would be the value of Q in 10 years? Okay. So let's draw the cash flow diagram first. So here, present sum of money is $60, right? So P is 60. And after 1, 2, 3, 4, 5, 6, after 6 years, so let's say is Q sub 6, okay? And at I, the interest rate is 5% annual interest rate. So the present worth of Q is $60, right? And this money will be received 6 years from now on. And at the same interest rate, what would be the value of Q? Okay, this is actually Q, right? At the same interest rate, what would be the value of Q in 10 years? Okay, so this is the 60, which is equal to Q, right? After 10 years. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So after 10 years, how much would it be? Okay? So let's say is Q sub 10. And we are using the same interest rate of 5%. 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is 0, 1, 2, 3, 4, 5, and 6, right? Okay. So this is the problem 3-37. So how do you get this future sum of Q sub 10 after 10 years? Here, Q sub 10 is equal to 60 times F given P. The present sum is given, so we need to use this, right? And 5% interest rate, and over 10 period after 10 years, okay? And let's find the compound amount factor at 10%. So you need to look at page number 613. Oh, I'm sorry. We are looking for 5%, right? So 5% interest rate is provided in the page number 613. 1.629. 1.629 is the compound amount factor value times 60. Okay? So it's going to be $97.74. Okay? This is the problem number 3-37. Okay. Then next, let's solve problem 3-41. A local store charges 1.5% each month on the unpaid balance for each charge account. In that case, what nominal annual interest rate is being charged, and what is the effective interest rate? Okay, so earlier we have learned that I equals R over M. Is that right? So we are working on the problem number 3-41. Okay? Okay, so in this formula, what is R? Small r. R is the nominal interest, right? Then what is I? I is the interest rate per compounding period, right? Then what about small m? Small m is the number of compounding periods per year. Number of compounding period per year. Okay? Oops. So, from the problem description, you know that I is 1.5%. In such case, what is the M? M is the 12, because there are 12 months in a year, right? And this is, the I is the 1.5% each month. Okay? So we should use M equals 12. So from this formula, what is the value of R? R is I times M, right? I times M, which is 0.015 times 12, or 1.5% times 12 is the same, right? So R would be 0.18, which is 18%. Okay? So this is the nominal interest. Then how about the effective interest rate? And we've learned that if effective interest rate can be obtained by this formula. I sub A is the effective interest rate, is equal to 1 plus R over M to the power M minus 1, right? And what is this? This is the same as I, right? So we can rewrite this formula as 1 plus I to the power M minus 1, right? Is that correct? So what is this? 1 plus, what is I? I is 1.5%, right? So it's going to be 0.015 to the power M. M is 12, right? To the power 12 minus 1. So what is this value? Okay, the value from my previous calculation is 0.195618. Okay. Oh, that includes this. Okay, so this is the answer. So it's going to be 19.5618%. This is the effective interest rate. And 18% is the nominal interest rate. Okay? Okay. Next, let's solve problem 3-42. Sorry, it's very dry, so I need to keep drinking water. Okay, so problem number 3-42. What interest rate compounded quarterly is equivalent to a 9.31% effective interest rate? So we are working on problem 3-42. So using the formula for effective interest rate, I sub A equals 1 plus I to the power M minus 1, right? So here we have 9.31%, which is same as 0.0931 is the effective interest rate, right? Which is equal to 1 plus I to the power M minus 1. And here we use m equals 4. Why is that? Because there exist 4 quarters in a year, right? 4 quarters in a year. So we're going to use m equals 4. And m is the number of compounding periods per year. You remember that, right? So here we have 0.0931 equals 1 plus I to the power 4 minus 1. So 1 plus I to the power 4 would be 1.0931. Is that correct? Now, if you raise to the power 1/4, that is, if you take the fourth root on both sides, what happens? It's going to be 1.0931 to the power 1/4 equals 1 plus I. Is that right? So I would be 1.0931 to the power 1/4 minus 1. Okay. What is this value? This value is 1.0225. Okay. Which means that I is going to be 0.0225. Okay. So this is going to be 2.25% per quarter, right? Or it's going to be 9% per year. Is that right? So those are the answer for problem 3-42. Okay, and next, let's take problem number 3-45. Let me drink another dip of water. Okay, so a student bought a $75 used guitar and agreed to pay for it with a single $85 payment at the end of 6 months. Assuming the semi-annual, which means every 6 months, compounding, what is the nominal annual interest rate, and what is the effective interest rate? Again, this problem is about the nominal interest rate and the effective interest rate, right? So you are working on problem 3-45. Okay. So a present sum of money, $75, will be converted to an equivalent future sum of money, which is $85. Is that right? At the end of 6 months. after 6 months. Okay? And we are assuming semi-annual compounding. So if you use the formula f equals p times 1 plus I to the power n, then 85 equals 75 times 1 plus I to the power 1, right? So here, one plus I equals 85 divided by 75, which is about 1.133. Okay? So I is going to be 0.133, which is almost 13.3%, right? Now, using the relationship, R equals I times M, okay? Because we know that I equals R over M, right? Here, I is 13.3%, and M is 2, right? Because there are 2 6 months in a year. So we are using 2 here. So the nominal interest rate R would be 26.6%. Okay? That is the nominal interest rate. Now, the effective interest rate. Which is represented by I sub A. Is 1 plus I to the power M minus 1, right? So here, 1 plus I is 13.3%, which is 0.133, right? And M is 2, because there are 2 6 month period in a year, minus 1. And these values are same as 0.284. So the effective interest rate would be 28.4%. Okay? This is the effective interest rate. And this is the nominal interest rate. Okay? Okay. And next problem is 3.64. Okay. So the United States recently purchased $1 billion of 30-year zero-coupon bonds from a struggling foreign nation. The bonds yields 4.5% per year interest. The zero-coupon bonds pays no interest during their 30-year life. Instead, at the end of 30 years, the U.S. government is to receive back its $1 billion together with interest at 4.5% per year. a U.S. senator objected to the purchase, claiming that the correct interest rate for bonds like this case is 5.25%. And the result, he said, was a multi-million-dollar gift to the foreign country without the approval of Congress. So assuming that the senator's math is correct, how much will the foreign country have saved in interest when it repays the bonds at 4.5% instead of 5.25% at the end of 30 years? Okay, so we are working on problem 3-64. Okay, so let's look at the first case. So basically, this problem, we need to compute the amount of repayments at the end of 30 years with 4.5% and 5.25% of interest rate, respectively, right? And then we need to compare the both of cases to see how much the foreign country have saved in interest. So the first case, let's say, is the repayment at 4.5%. Okay? In such case, present sum is $1 billion, right? And F given P and 4.5% after 30 years, right? Or another expression is 4.5% is 0.045 to the power 30. And it's going to be $1 billion. And let's compute this value. Okay. So these values is 3.745. Okay. So if you multiply by $1 billion, then how much is that? It's very easy. $3.745 billion. Okay. What about the second case? Is the repayment at 5.25%, right? In such case, present sum is same, $1 billion. And F given P 5.25% over 30 years. Another expression is 5.25% is 0.0525, right? To the power 30. And what about this value? It's going to be 4.62. So if you multiply by 1 billion, it's going to be $4.62 billion. So if you compare these two values, repayment at 4.5% is $3.745 billion, and repayment at 5.25% is $4.62 billion. So by comparing these two values, you can say that the savings to foreign country would be $4.62 minus 3.745. How much is that? $5, 7, is that 8, right? So $875 million. Okay? So those are the amount of money savings to the foreign country. Okay, then okay, so this would be the last problem for today. And this is the last problem that we are going to solve from the end of chapter 3 from our text. Okay. So the Apex company sold a water softener to Marty Smith the price of the unit was $350. Marty asked for a deferred payment plan, and a contract was written. Under the contract, the buyer could delay payment for the water softener if he purchased the coarse salt for recharging the softener from Apex. At the end of 2 years, the buyer was to pay for the unit in a lump sum with interest at a rate of 1.5% per quarter year. And according to the contract, if the customer ceased buying salt from Apex at any time prior to 2 years, the full payment due at the end of 2 years would automatically become due. And 6 months later, Marty decided to buy salt elsewhere and stopped buying from Apex, whereupon Apex asked for the full payment that was to have been due 18 months hence. And Marty was unhappy about this, so Apex offered as an alternative to accept the $350 with interest at 10% per semi-annual period for the 6 months that Marty had been buying a salt from Apex. Which of these alternatives should Marty accept? Explain. So we have a pretty long problem descriptions for this problem. So we are solving the problem 3-65. Okay. So let's consider the first case, the lump sum payment. For the case of lump sum payment, the $350 times F given P, and in that case 1.5% interest rate need to be considered per quarter year, right? So 1.5%. What about N, the value of N? It's going to be 8. Why is that? How many quarters do we have in 2 years? There are 8 quarters in 2 years, right? That's why we need to use N equals 8. Because here the Marty pays 1.5% per quarter year, per 3 months period, right? So the N should be 8 in this case. So let's look at the table values. The compound amount factor for 1.5% is given in page number 600. And the value is 1.126. 1.126, okay, times 350. And what is this value? Okay, so the final answer for this case would be $394.10. Okay. What about the second case? Let's say that is the alternate payment. This case is the same amount of money, $350, and F given P. Now, how much percent you're going to use? The company offers 10% per semi-annual period for the 6 months that Marty had been buying a salt from Apex. Okay? So we are going to use 10% per 6 months period, which is semi-annually, for the 6 months, right? So the value of N would be 1, because there are 6 months within a 6 months, right? So again, we need to look for the compound amount factor, this time at 10%. F given P. Okay, so you need to look at page 613. So in this case, it's 1.1 times 350. Okay, so how much is that? 35. So 385, right? So what is your answer? Which payment method you need to choose? Definitely you're going to choose alternate payment. Okay? Because the payment amount is smaller than the lump sum payment case. Okay? So choose the alternate payment. Okay? And there was problem 3-65. Okay, so this is all for today. So next time, we're going to move on to the next chapter, chapter 4. So please read the main contents of chapter 4 before you watch the next lecture. Okay? Thank you very much. Bye-bye.